All right, children, we got our a little bit of an extension of proofs here for our second stretch of Unit 7. We're going to be adding in some extra properties here and there, so we'll be jotting those down, but we'll be using them in the context of a proof itself. All right, so I've got this triangle here, I got a couple triangles here, and my given says that CD bisects angle ACB, and then I also that AC is congruent to BC. Well, I know that AC is congruent to BC would just be this, but what the heck does CD bisecting ACB mean? Well, what we're talking about is it's taking this angle right here, ACB, right? This guy right here. Why don't I just mark it with, there we go. So this angle right here, ACB, right, the big guy. And when it bisects it, when CD, this ray right here, that's what it means when it has an arrow above. That means it's a ray. It's bisecting the angle. What do you think it means to bisect? Well, if I said, hey, could you take that 8-foot 2x4 and bisect it for me, right? You would know, oh, I'm going to cut that in half. That's all it's doing. It's cutting it in half, or in our math lingo, it's cutting it into two congruent parts. So what I'm getting out of this is this angle, oops, there we go, is congruent to this angle. All right. So I get two congruent angles when it's been bisected. All right, so I'm gonna shrink this down a little bit, give us a little more room to write. Let's see here, there we go. And let's write up our proof here with what we've got. We got to add a little bit more in, but we're almost there. So I've got my given. All right. And then, let's see here. All right, so I was given that AC is congruent to BC, but now I need to say angle ACD is congruent to angle BCD. Okay. My reason for that is that it's been bisected, right? It's the angle bisector. So I could say definition angle bisector. Okay? Or you could say an angle getting bisected splits into two congruent angles. Like if you don't remember the actual definition name, you can explain it in words. That's totally fine. All right? So maybe down here we'll say angle bisect gives you two congruent angles. All right, a very informal definition there, right? An angle bisector gives you two congruent angles. That's something I might jot down there as being our definition of an angle bisector. Okay, so I've got two congruent angles, I've got two congruent sides. So I either need another two congruent angles or I need another two congruent sides. Well, if you remember from the first half, we'll say, of this chapter, reflexive property would give me DC congruent to itself. So let's state that. DC is congruent to DC, and my reason would be reflexive property. Ooh, that's a terrible writing of property. Property. All right. Now I have congruent triangles. Triangle ACD is congruent to triangle BCD. And what's my reason there? Well, I have side. I have two sides and an angle. Well, it would be side, then the angle, then the side. So SAS. Side, angle, side. Cool. There we go. We got our four wonderful, wonderful step proofs. Excellent. Let's do another one. All right, we got another proof here. We're going to add another couple exciting definitions and properties. So I've got AD is perpendicular to CB. We've heard that before, but we haven't used it formally in proofs. AC is congruent to AB, and I want to prove the two triangles congruent, right? Okay, cool. So why don't I first mark down the AC is congruent to AB. All right. Now, let's see what else I could do here. Well, perpendicular. What does it mean to be perpendicular? Well, to be perpendicular means I have right angles. It means that AD forms right angles with that line CB down there. So ADB is a right angle, and ADC is also a right angle. Right? I got two right angles. And what do you think you know about right angles? Well, you might be saying, oh, they're 90 degrees, things like that. Well, could I also say that right angles are congruent? I think that'd be helpful in a proof, right? To prove those angles are congruent. And yes, you can say that right angles are congruent. So let's go with that. We've got that those are congruent. I need another piece of information. Some of you might be thinking, well, why don't I just throw in the reflexive property? AD is congruent to itself. Well, that would give me an angle side situation, okay? And that's not going to work, okay? So that would actually, there's a different congruent property that we're going to not get into quite yet. So we'll leave it there, that AD being there, that's going to yield an angle side situation, which we can't work with here. All right, that's not something that works. We showed ourselves in class using some boards that does not work. So I got to have something else. Well, I've got a thought for you. If these two legs, AC and AB, are congruent, do you think it would make sense? Like, does it make sense to you that these two angles would be congruent to each other? I mean, it's going to be an isosceles triangle, right? If AC is congruent to AB, it's going to be an isosceles triangle because the legs are congruent. It makes sense that my angles are also congruent. And that is absolutely true. So we got three really new pieces of information we need to jot down, okay, before we start this proof. So first one, if two segments are perpendicular, then they form right angles, okay? So we get right angles out of that. You can just write definition perpendicular. I'm okay with that. You could even do, definition perpendicular. That's the perpendicular symbol. We've seen that. Obviously, that's also in our given, so I'm okay with you writing that. All right. And of course, if the two lines are perpendicular or two rays are perpendicular, you still get the right angles. All right. So that word segments, you got a few things that would work with that. All right. Our next one, we talked about how the right angles would be congruent. Simply put, that is just all right angles are congruent. So if you get right angles, you can say that all right angles are congruent. Cool. And then our last one, we're talking about those the legs being congruent, giving you the angles being congruent. So if two sides of a triangle are congruent, then the base angles are congruent. And you can actually reverse this one. If the base angles were congruent, it would also follow that the sides are congruent. The way I like to write this one out is with symbols. So I say if my triangle, if the legs are congruent, then the base angles are congruent. Or if the base angles are congruent, then my sides are congruent. Okay, so I am going to use these two in my proofs rather than writing it out. All right? Cool. You could say here I see some people do this, right angles congruent. I've seen that drawn up, but that gets a little bit symbol-y. But if you want to do that, I'm cool with that. I'm Gucci with that. All right, let's do this proof here. So for this one, still starting out with our given. Step 2. Why don't we deal with the perpendicular first? First off, we get right angles, right? So angle ADB and angle ADC are right angles. And that's our definition of perpendicular. Cool. So far, so good. So I've established that I have right angles. If you wanted, you could write angle 1 and 2 in there, like you could draw a 1 and a 2 and use that in place of what we just wrote down, okay? I decided not to do that. Alrighty. Now I want to say that, hey, those angles are congruent. So angle ADB is congruent to angle ADC. And my reason for that is all right angles are congruent. That's usually my abbreviation. I do right as RT period. Okay, so I've got those two angles congruent. I've been given the sides AC and AB. Now I need to get my base angles. So angle C is congruent to angle B, and my reason for that is if the sides of the triangle are congruent, then my base angles need to be congruent. And it has to be triangles we're dealing with, okay? Can't be any of those shapes. Okay, so I've got two angles, two pairs of angles, and a side. So I've got, is it angle side angle or is it angle angle side? Well, when I look at this, if I go with my, if I look at my two angles that I have, I'm going to focus on those. This angle here and then my right angle. Is the side between those two? No, so it's not angle side angle. It has to be angle, then an angle, then a side. You might be saying, well, I can go angle, side, and then whip around for an angle. I get what you're saying, but that would have to be this angle up here for that to be the case, okay? So is your side between the two angles you say are congruent? No, so it's angle, angle, side in this case. All right, so let's get my congruent triangles. Triangle ACD is congruent to triangle ABD. Angle, angle, side. Cool. Awesome. That was lovely. We added ourselves in 3 on this bad boy, and then was it 1 or 2 on the previous one? So lots of new properties here. We're going to do another video with some more properties, and we'll do some practice problems in class on those.